Hello, everyone. I'm Tom Spinelli. I am the administrative partner at Omnitek Partners. Although we're in the open topic portion of the showcase, our technology is related to power and energy. We are a technology development company. We've been developing mostly military technology for over 20 years, and we've successfully developed some of military products for tier 1 and 2 defense contractors. And those products were initially based on SBR development contracts. However, we also commercialize some of our technology, our military technology, and this electronic battery conditioning technology is one of those. Next slide. I think you could skip this one also. So I've reproduced some headlines, recent headlines from various automobile manufacturers, all pledging to transition to 100% battery power within a short term, 5 to 10 years. And not only these automobile companies, but I guess companies that are peripheral to automobile companies like Uber and FedEx and other similar companies. Next slide. So there's no doubt that automotive industry and other industries are heading towards being completely electrified or taking advantage of powering their devices, products with batteries. Siemens has also developed a train that's completely electric, and the list goes on and on. Power tools, lawnmowers, tractors, snow blowers, drones are in the news a lot by being used for deliveries by Amazon. They're all electric powered. Next slide. So what all these have in common are batteries, the need for batteries, the need for inexpensive, long-lasting, efficient batteries. Most people are familiar with the high cost and short life expectancy of these type of batteries. The battery of choice right now is lithium ion. It's gotten some bad press recently because of the environmental impact it has on mining the lithium. But other batteries, or the similar batteries, are being presently developed, but they all suffer from the same disadvantages. Most people, however, do not understand or realize that they have another common disadvantage, and that's they do not charge, or they charge inefficiently at cold temperatures. And when you try to charge them at the cold temperatures, it actually damages the battery, making them less efficient and reducing their life expectancy. Next slide, please. So yeah, the graph on the right illustrates just how significant this problem is, and it's for nickel, cadmium, and lead acid batteries, but lithium ion and all other batteries, similar batteries, suffer from the same disadvantage. So you can see at a relatively high temperature, like 25 degrees C, which is about 77 degrees Fahrenheit, that batteries already start losing some of their cranking power, the power that's available. And going down to about 0 degrees, which is room temp, which is freezing, 32 degrees Fahrenheit, they've already lost 40% of their cranking power. And as I mentioned before, when you try to charge batteries at very low temperatures, they are damaged, and that damage is irreversible. What some car companies do now to try to combat this problem is they use heating blankets and insulation on the batteries, which heats them inefficiently from the outside. The core still remains cold even though they're heated. So those type of solutions are generally expensive, and they're fairly inefficient. Next slide, please. So our core technology is, and I'll simplify this for everyone. We input the battery before charging, prior to charging the battery. We input the battery with a specific type of current that is that effectively shortens the internal capacitance of the battery and results in heating the battery, the core of the battery, from the inside. And it can be done very efficiently. It can be done quickly, and it does not result in any damage to the battery. Next slide. Yes, thank you. We have
30-second warning.
We have a lot of technology covering our battery conditioning. We have several patents already issued and several others pending in the US and in foreign jurisdictions. Next, please. We have integrated this technology in several ways into a charger as an adapter between the charger and the product, but our preference is to integrate it directly into the product, such as in the case of a vehicle in their battery management system. Next, please. So as I said, this technology is completely safe. It works on all types of batteries, including lead acid, lithium ion, other types of rechargeable batteries. It brings the battery temperature to its optimal temperature before charging, so that when the battery is ready to be charged, it charges efficiently and without damage. It increases the amount of electrical energy to the battery, which results in an increase in range of the battery and also increasing the life of the battery. And as I mentioned with regard to that graph, it's not just for very low temperatures. It's maybe more useful at low temperatures, but it's useful at temperatures as high as 70 degrees, because there is some slight damage and there is some slight loss of power even at 70 degrees. Next slide, please. So we are not looking for capital. We are looking for licensing opportunities. So mainly looking for contacts with the manufacturers of the products. We are not looking to with contacts for battery companies or charger companies. We want to integrate the product, our technology directly into the product. So we're looking for licensing opportunities and contacts with manufacturers.
Excellent. Okay, I think we'll hold it here and we'll talk about the team at another time. Any questions for Tom?
One.
What do you see as like what do you see as the highest value targets for integrating products?
I'm sorry, Justin, can you repeat that?
What are the highest value targets for you as far as integration with what types of products? Where do you see yourself fitting in?
Oh, no doubt, automobile.
Okay, is there a second place in there?
I think heavy industries. We have an opportunity right now with a manufacturer of heavy industry equipment, and that's used in cold environments like freezers,
Cold storage,
freezer, right? And we're pretty far along with them, but I think a lot of outdoor equipment and heavy equipment could be a next big opportunity.
Okay. All right, fair enough. Thank you.
How do you deal with hysteresis with your technology?
Oh, Jay, are you available?
Battery hysteresis. It happens with every type of battery at one form or another.
Right. I can't answer that question for you. My staff scientist is supposed to be on with me, and I don't see him on. But I can get back to you on that, John.
Yeah, thanks. I dealt in cellular batteries for a long time that tend to develop it because you're recharging over and over and over, and at a certain point you build up that chemical hysteresis.
Right. Is that a problem with lithium-ion batteries?
Less so. Less so. But it can exist theoretically with every kind of battery. With your metal hydrides and your cobalts and things, it's very much a problem. And
yeah, this is Jay Rastigar. I was going to, for some reason, I wasn't on the connection. Hysteresis is what we are using to heat the battery.
Good. Okay. Got it.
Okay, so that is a process of heating.
Interesting.
Mm-hmm.
So you're monitoring voltage and amperage and over time.
Right. In other words, we are applying very, very high frequency, and with very high frequency, the ions inside the electrolyte is going to move back and forth, effectively vibrates, and that's the source of hysteresis, and which increases the temperature. It generates heat.